Hello, viewers. This is Chetan Kumar again from Stiblop Academy and Consultancy. I welcome all of you to yet another session of the product design and development. So, I hope you remember in the previous session we discussed about advanced design criteria and also on the interface managements. So, in today's session, I will teach you about the preliminary design and development of the product design and development process. So, this is a pretty big design phase in the product design and development process. So I'm going to take you through these sessions in two different parts or maybe three parts. So without wasting any time, let's jump into it. Yeah, preliminary design and development, part 1. Friends, I hope you remember that during the concept design phase, the concept gets frozen at the end of that particular design phase and comes as a input to the preliminary design and development phase. So that is a frozen concept and it is reviewed and selected by the product design and development team along with the cross-functional team. And the cross-functional team has approved that concept to go ahead. So that concept forms the maturity in the preliminary design and development phase. Okay. Yeah, let's look at the definition. Preliminary design and development is a design phase that matures the design. So let's try to understand what's the purpose of this. The purpose of this is to optimize the concept design according to advanced design criteria, to initiate the mockup analysis in the product environment and report for any clashes or the clearances, to verify the design, to develop a prototype for the testing. Okay. Now let's look what are the learning objectives in today's session. So first, let's try to understand the process and then freeze of the interfaces and then derivation of the design specifications. Okay. And the rest of the things I will cover it in the part 2. Okay, so this is the design and development process which we have been following right from the beginning. And the output of the preliminary design and development phase is the proto release. So you will understand what this proto release is at the end of this session. Okay, now let's go through the process. Okay, the first and the basic step in the preliminary design and development process is receipt of the frozen concept, as I mentioned you before. And here in our case, I hope you remember the concept that is frozen is channel and the divider concept. Okay. Yeah. So in the first step, what we actually do is that we receive the number of the parts. I mean, we receive the BOM of that particular concept. And that BOM will show you how many number of the parts are the reusable parts from the previously designed product and how many are new parts. Next input that we get is the weight of the machine. And of course, the functionality, it's already working as I have shown you in the concept design. Yeah, the next immediate step that comes in the preliminary design and development process is the input study, like all of the process. So in this input study, we decide the reusable parts. We understand the packaging requirements. We understand the advanced design criteria requirements, and we check what are the pending targets. Next is inputs. We check if there are any inputs missing. If no inputs are missing, then we proceed towards definition and freeze of the secondary interfaces. If there are any inputs missing, then we approach the PM to get those inputs. Okay. Yeah. In the step that involves a freezing of the secondary interfaces, we establish the secondary interfaces and the left out primary interfaces with the mechanical connections that you will understand once I take you through the subsequent slides. The next step that involves in this process is derivation of the design specifications. See friends, let me just explain you that process once again. The first process is definition of the product requirements. The second step is derivation of the functional requirements from those product requirements. The third step is derivation of the design specifications. Okay, so we have come across all these things through our uh, input study, I mean the pre-study, next feasibility study, and the concept design. Okay, so in this phase we will derive the design specifications. So I will show you what it is. Yeah, the next step is the actual design and development loop. So here the engineer or the engineering team selects the materials that is required for the machine. And next is the design optimization according to the advanced design criteria. Okay. Next step, mock-up analysis. I will explain you what is mock-up analysis is. Then DFMEA, this also I will explain you. Then comes the actual development too. So in this development too, what happens is the engineering team takes the results of the mock-up analysis and the DFMEA and they further mature the design. The next step is the design verification. Yeah, in this step, the verification of the design is done with respect to the payload target. Okay. Yeah, once the design verification is done, the results are shared back to the product development team and then they incorporate those results into the design to get the next level of the maturity. So that is nothing but the nth design loop or the third design loop. This is a continuous process where after this loop again the design is submitted to the design verification and the verification team analyzes the design and again give them back to the uh, product design and development team. Basically the design verification team is the CAE team. CAE is nothing but computer aided analysis where they virtually analyze your design in the system. So they are also called as a calculation team in the vehicle engineering. Okay, they they divide your models into a number of elements, finite number of elements. They try to analyze each element with respect to the static analysis, dynamic analysis, frequency modular analysis, and lastly the fatigue analysis. So all these analyses are carried out and finally we get the most matured 3D model of the preliminary design and development. Okay. So as I was explaining before, this is a continuous process and it keeps on running the loop until the payload target is achieved. And once the product design and development team is confident that they have achieved the necessary target, it is subjected to the design verification SME team. Okay, they check whether our design is okay as per the defined payload target. Okay, if it is okay, then it is subjected to the next level of SME evaluation. If it is not okay, then it is subjected back to the development loops again until the PD team achieves that target. Of course, the CI team also helps them in achieving the target. They show where the stress concentration is high and where the strength has to be improved and things like that. Okay. Now let's see what happens in the SME evaluation. The SME evaluates that the design is okay for the prototype development or not. If yes, the PD team proceeds with the prototype release. If no, they rework on the design based on the SME feedback and again it is subjected to the SME evaluation. Yeah, now moving on. Yeah, this is the overview of the preliminary design and developed fruit auto sorting machine. Okay. So this is the complete machine that the team has developed. See, this is the environment data, this is the fruit collecting net, and this is the divider through which the fruit falls and the gate rotates either clockwise or the anti-clockwise and directs the fruit into either of the bins. Okay, and you can see here on your right side that this is the gate rotating mechanism and the support bracket. Moving on. Okay. So this is a very, very important step in the preliminary design and development process. Freeze of the secondary and the priority two interfaces. I hope you remember the freeze of the primary interfaces in the concept design and development phase. Yeah. Similarly, we have to freeze the secondary interfaces here. Okay. Now, one of the primary interface that was left out without freezing was the fixation of the net to the stand. So it is fixed by means of the hat profile bracket here. Okay. Let us see which is the next one. Here, the next secondary interface that has to be frozen here is the fixation of the support bracket to the stand. You can see that this is the support bracket that holds the entire universal joint and this worm and worm gear joint. Okay. So this is mounted onto the stand by using the again self-tapping screws. Okay. The next one is the fixation of the yoke sleeve to the gate. Okay, initially in the concept phase, this was a single piece. Now it is separated and it forms another secondary interface. Derivation of the design specifications. This is very important step in the preliminary design and development phase. The derivation of the design specifications is done from the functional requirements. I hope you remember that the functional requirements were realized in the concept design and development phase. The first one was the concept design of the speed reducing mechanism. Second one was the concept design of the mechanism which is used to shift the gate from the right to left and left to right. You can call it as an oscillating gate mechanism. Now let's see what are the design specifications that got derived from those functional specifications. Sorry, functional requirements. Yeah, the input that is available with us is the lead of the worm is 6 millimeters. Okay, and the standard RPM of any motor that can rotate lead stick worm is 600 RPM. Okay, the required speed of the gate is 10 RPM. Now, what is the output that we get from that? So, before that, what I am trying to say here is whatever I have highlighted in blue, that is the design specification. This first design specification was already derived during the concept design and development phase. Okay. Now, in this phase, we are deriving a few more design specifications. Let's see how. The velocity ratio is the speed of the driven divided by the speed of the driver. So it is 10 rpm divided by 600 rpm, it comes to around 1 divided by 60. And the formula for the velocity ratio is the lead divided by the circumference of the pitch of the worm wheel. So from this formula, we derive what is the pitch circle diameter of the worm wheel. Okay, so it is 114 mm. So this is another design specification. Next, teeth that has to be cut on the worm wheel. We know that the pitch of the worm wheel is equal to the circumference of the worm wheel. I mean the pitch circle circumference of the worm wheel divided by the number of teeth. Okay. So from this particular formula, we arrive that the teeth that has to be cut is a 60 numbers. Okay. Now I will just show you. This is the concept design and development data where you don't have anything. None of the teeth are cut on the worm or the worm wheel. And this is the preliminary design and development data where you can see that the teeth are cut and also we have the hook joints. So this is all about the derivation of the design specifications from the functional requirements. Now in the part 2, we will see what are the other activities that happen after the derivation of the design specifications as per our preliminary design and development process. Stay tuned.